I'd like to do a second example of how we determine the equation of a line if we're given a parabola, or specifically given the graph of a parabola. So again, the first thing you want to be able to identify is where is the vertex of this particular parabola. And in this particular parabola we have on the right-hand side, the vertex is right here. Okay, and so the vertex of the parabola is very helpful because we know what the vertex form of all parabolas is. Okay, and so we know that the vertex is the same as the hk values. Okay, and so the vertex here is actually at 3, -7. Okay, so the vertex is 3, -7. That means that h is 3 and -7 is k. Okay, and so we can fill that piece in right away. So h is +3 and k is -7. We know that the direction of opening in this, just by looking at the parabola, is up. Okay, so that automatically tells us the a value is going to be a positive number of some kind. Okay, so now what we need to do is we have to identify the step pattern. Okay, and so there's a couple ways that we can do this. So one way that we can identify the step pattern is through using our actual step chart that we've been talking about. And so we've got x, y1, and y2. Okay, we know that y2 is equal to y1 times a, and our normal step pattern goes up 1, 4, 9. And in this particular instance, if we go over 2, we know that it's gone up by 2. Okay, if we go over 3, or sorry, over 4, it's gone up by 1, 2, 3, 4, 5, 6, 7, 8. So there's another one. So if it goes over 4, it goes up 8. Normally it'd be 16. Okay, so if we want to figure out what the a value is, you could do a is equal to y2 divided by y1. Okay, so even though if I go over by 1, I have this kind of nebulous, I'm not really sure what that number is because it's not at a specific point of intersection, but I do know for a fact that y2 is on a specific point. So in this case, we've got y2 divided by y1 is equal to a. And so y2 is 2, y1 is 4, so a is going to equal 0.5. Okay, so positive 0.5. So we can get that from the step pattern. There is another way that we could do this. Okay, for those of you who feel more comfortable doing it this way, we also know the position of a couple other points on this graph. And so, for example, here, we know that this point is at 1, -5. Okay, and because that point's at 1, -5, we know that that has an xy coordinate. Okay, so the x coordinate is 1 and the y coordinate is -5. Okay, since we know that the vertex form of the parabola of the quadratic equation is y is equal to a times x minus h squared plus k, we can actually substitute in the values of x, y, h, and k and then solve for a. So for example, we know that y is -5. We wouldn't know what a is. We know that a is 1. We know that h is +3. So minus +3 all squared. And we know that k is -7. Okay, so now we just go through and we solve. So -5 is equal to a times 1 minus 3 squared minus 7. So -5 is equal to a minus 2 squared minus 7. So -5 is equal to a times 4 because negative 2 squared is 4 minus 7. So now we got to get this piece over. So we're going to add 7 to both sides. So that's going to give positive 2 is equal to 4a. A is equal to 2 divided by 4. A is equal to 0.5. Okay, so that's just a second way of doing it. Okay. So as we go through, we now have, we're now asked to figure out what the equation is. So the equation in vertex form, again, remember the equation is always in the form y is equal to ax minus h squared plus k. We're going to substitute in what we know. So we know for sure y is equal to 0.5 x minus 3 squared minus 7. Okay, so a couple different ways to go about actually figuring out what the equation of a line is, or equation of a parabola is from just a graph. You can either use the step pattern or you can use algebra if you have 2 points on the line that you can identify. If you have the vertex and a different point on the line.